We're going to look at how do we do relations and functions from different forms and what expectations we need for Brougher's class. This form of function relation is called a mapping. This mapping requires the circles, but it also requires you to define domain and range. Domain is going to be on the left and range is going to be on the right. Please label your domain and range. For our domain and range, the input is our domain. That corresponds to the x-axis. The output is the range. That corresponds to our y-axis. -1, 2 tells me a coordinate. -1, -2. 1, -1 tells me a coordinate. I have a mistake here. Let's fix this. -1, -2. -1, -2. 1, -1. 1, 0. 2, 2. 3, 2. This point here is really just our axes. There is no coordinate there. We need to know if this relation is a function. There are two different answers that you will be giving for a function. Either yes, it's a function because each input goes to exactly one output, or no, it's not a function because input blank goes to both output blank and blank. Here I have input 1 goes to both output -1 and 0. That means it's not a function. We are going to follow this format exactly. Not a function. Input 1 goes to both output -1 and 0. Take a moment to try to go backwards from this graph to this mapping. Remember to label the pieces that you need. We should have our domain and range circle. We should have domain. We should have range. Our domain, we're going to start from the left and go to the right. That's going to tell us our inputs. I like to use a ruler to help me out so I can map. Starting on the left, the first place I hit the graph is at -2. The next place is -1. The input here is 0, and the input here is 1. I'm then going to find my range going from bottom to top. I'm going to change colors to green. The first place I hit is -3, then -2, then 0, and finally 1. Notice that when I hold the ruler here, there is no part of the graph that I am touching. That's why I have different unique numbers instead of a range. So we're going to map from here. Input -2 goes to output 0. It also goes to output -3. Input -1 goes to output 1. Input 0 goes to output -2, and input 1 goes to output 1. The domain and range must be mapped from least to greatest with no repeating numbers. Now the question is this a function? This is not a function. Can you figure out why? Input blank goes to both output blank and blank. While our input that goes two places is -2, goes to both outputs, -3 and 0. We've learned in the past that a table is the same as a graph, so we can simply take a table and make a domain and range mapping. domain, range. Make sure that you highlight your circles because we're going to have those mapping bubbles. And then from here, take a moment to see if you can solve this on your own. Pause the video and just see what you can do. Did you remember that your domain needs to go from least to greatest with no repeat? So I'm not going to say the 1 twice. Did you remember your range goes the same way? And then we're going to connect that positive 1 goes to -2, -3 to -1, 1 to 0, 2 to 2, and 0 to 3. Is this a function? This is not a function. Input, positive 1, goes to both output, -2 and 0. Number 4 is a little bit different. We need to read it carefully. It says, given the scatter plot means not connected points. I need a set of ordered pairs. Set means I have these squiggly brackets. Ordered pairs means I have coordinates. When I do a set of ordered pairs, I need to make sure that I organize the input, that's our x coordinate, from least to greatest. And we close off with our set brackets. I find the ruler very helpful. The first point, I have -3, 0. The next point I hit is -2, -3. Next is -1, 1, with a comma in between, 0, 2, and 1, -1. We have a mapping, a graph, a table, and a set of points. Now, is this a function? This one actually is. Yes, function. Each input goes to exactly one output. All right. Pause the video and see what you can do for number 5 through 7. I want you to just answer, is it a function or is it not a function? Make sure you have the entire statement that you need for the answer. Is it a function? Yes. Each input goes to exactly one output. Is it a function? No. Input blank goes to both output blank and blank. I like to call these little crosshairs. Those are 2 very nice crosshairs. I would use those 2 coordinates, not a function. Input -1 goes to both outputs 3 and -1. Could you have chosen other points? Absolutely. You could have chosen those 2 and estimated, those 2 and estimated, but that's a little hard. This one is also a function. So we're going to talk domain and range. I'm going to use red for domain and green for range. In class, I talked about, imagine you could take this graph and you could squish it to the x-axis. Where would it sit? Some of you are struggling with that. So in this course, I'm going to show a little different way of doing it. I'm going to start using my ruler to help me pretend I'm tracing the x-axis for the graph. Anywhere the side of the ruler touches, if I can see part of the graph, then I am, when I go left to right, in the domain of the graph. Not in the domain, no graph here. Almost in the domain, this is an open circle. As I move to the left, I end the domain here, and I'm no longer in the domain. So here's a strategy I've learned. I like colors and it helps out. I'm going to start with the first place I see the graph. If I don't see an open circle, it's always closed. This is open. I'm going to put my pencil down or my pen, where I start the graph. So as we can see, I'm here. And I'm going to push the ruler this way and trace with the pen at the same time. As long as I see part of the graph. Now this is where the graph stops. So I'm going to make a mark to say that I've finished. This is the domain of the graph. So here's my X number line. That starts at -2. That ends at 2. And I shade it in the middle, so X is in the middle. We're always going to eat or have the inequality towards the biggest number. -2 must be smaller than X must be smaller than 2. But I'm also going to look at open or closed. -2 was open, not equals. 2 was closed, equals. We just found the domain of our graph. So we're going to write D for domain, colon, set X such that, what's our rule? Exactly what we just wrote. -2 is less than X is less than or equal to 2. The range is going to look the same, but going from bottom to top. So I'm going to start down here. I'm going to say, where's the first place I see my graph? Right here, open circle at -2. I'm going to trace for a moment going up and down to see where do I see the graph. That gives me an idea of how much I'm going to be tracing. I'm going to put my pen down. And as I move the ruler up, as long as the ruler is touching part of the graph, I'm going to keep my pen down. As soon as I get to the end of the graph, the pen is going to come up and I'm not going to draw anymore. It ended at a closed circle. I have a really hard time seeing this from bottom to top. So I'm going to take my test or my packet. I'm going to turn it sideways and I'm going to look at my Y number line. The Y number line starts at -2. It ends at 1. And the Y is in the middle here. So I'm not equal to -2. I'm equal to or less than 1. I now have my inequality for my set notation. The range is the set of all Y such that -2 is less than Y is less than or equal to 1. And we're going to close that set notation. I'm going to highlight this in blue so I can see it. Did I ever have a repeated input or a repeated domain? No. So this is a function. Each input goes to exactly one output. I'm going to do that again for number 6. I'm going to start with my red for my domain. I'm going to say, where's the first place that I see the graph? The first place I see is here. So this ruler, the edge of this ruler is acting as my check of, do I have part of the graph? When I go here, I have 2 parts of the graph. When I slide it over, I keep having 2 parts, 2 parts, 2 parts until I get 1, and now there's no more graph. So I'm going to start here. If there's no big open circle, then it's closed. I'm going to use this to help me graph. I have part of the graph, I have part of the graph, I have part of the graph. This is the last part, pen up, and I move off. So where is this? Well, this is -3. This is +1. I get to equal -3 and I get to equal 1. So what's the domain? The domain is the set of all X such that, well, if I shade it in the middle, X is in the middle. I get to equal -3. I get to equal 1. Remember, the inequality always wants to eat the bigger number. -3 is the smallest side. It's on the left. 1 is the biggest side. It's on the right. X is in the middle. So -3 will lose to X, and X will lose to 1. 1 is the absolute biggest. -3 is less than or equal to X is less than or equal to 1. And I close my set notation. I'm going to do the same thing going from the bottom to top. No open circle, so it must be closed. Pen down, ruler down. I'm going to test my guide. Looks like I always have somewhere on the graph. And then I'm going to draw. And I'm going to go straight up until I hit the edge of the graph. And I'm going to mark it, and I'm going to move off. This was at -1. This was at 3. So what's the inequality? -1 is less than or equal to y, because I'm going on the y-axis. It's less than or equal to 3. We have found our domain's range. Range is the set of all y such that -1 is less than or equal to y is less than or equal to 3. Number 7 is a really great example of why I use this ruler to help me out. We're going to start with our domain. On the left, I have an open circle, and then I get graph. This actually doesn't exist as a point. As I move from left to right, I have part of the graph, I have part of the graph, I have part of the graph, and when I end, I don't have graph anymore either. So I'm going to start mapping my domain. Starting on the left, pen down. There's part of the graph, part of the graph, part of the graph. I can see it. And then pencil up because I hit an open circle. No more drawing. Take a moment to see if you can write this inequality for your domain. Did you remember it's not equal, so you don't put your equal? Do your inequalities all point towards the biggest number? They open up to eat? Let's try our range. I did do that in the wrong color, so I'm going to fix it real quick to match. This is our red. Now the range is a little bit different. When I start here, is this open or closed? No open circle, so it must be closed. When I move up, I can see I hit 2 range spots, 2 range, 2 range, and then I get to here at range -2. This is open. That's not a part of the range. This is open. That's not part of the range. This is closed. That is part of the range. So even though I see 2 open circles, there is a range at -2. It's just not at the edges. Then I get 2 range, 2 range, 2 range, and then up here, this is closed. That is part of the range. So I'm going to start down at the bottom, pencil down, trace up until I run out of graph, and we get from -4, we get -2, and we go all the way up to 0. Write your range. Is this a function? Yes, it is. Yes function. Each input goes to exactly 1 output. When I have coordinates like the first 4 problems, our domain and range are a list of numbers. If I graphed this, it would turn into a graph similar to 11. If I graphed this, it would turn into a graph similar to 11. If I graphed this, it would turn into a graph similar to 11. Why? If there's no equation, we don't know if we can connect points. Unless we're told continuous. I'm going to do an example with a set of distinct points here. My domain is the set of all coordinates pieces in X where X is equal to, we need to go least to greatest, -2, 4, 5, and 10. These were all separate. We couldn't put them together in an equation, so they're separate listed here. Try your range. What do you get for your range? Now, this is function notation. In function notation, this piece here inside the parentheses is your input. The whole thing is the output. Output goes to Y, input goes to X. So this is saying, what is your output when 10 is your input? It's asking us, what is the output when I plug 10 into the input? Well, that matches one of our coordinates, 7. Whenever you give a function notation, also answer in a coordinate. Take a moment to do 9 and 10, just like you do with number 8. How did you do? Let's look at the difference between a discontinuous and a continuous set of domain points. Discontinuous means disconnected. Discontinuous, disconnected. Continuous is connected. I'm going to use my ruler again to help me out, and I'm going to start with my X's. Using the drawing technique, I find this makes it really clear. So where I don't have a point here, I'm going to move to the right. Oh, there's a point. But then I got to pick it up because there's no point, no point, no point, point. No point, no point, no point, point. No point, no point, no point, point. Where are these? Well, this is X equals -2, X equals 0, X equals 1, and X equals 3. That is where my inputs are. Which means my domain, D, is the set of all X, where X is equal to, from least to greatest, -2, 0, 1, and 3. Let's compare number 11 to number 12. Where do I start with my domain? Well, with my domain, the first place I'm going to hit part of the graph is here at 0. And I'm going to watch when my ruler is touching part of the picture, and my pen is just going to draw straight until I run out of picture. And I run out of picture at the open circle, no more. This goes from 0 to 8. X is in the middle, and I can equal 0. So here my domain is the set of all X, where 0 is on the left, I shade in the middle, and 8 is on the right. Discrete or discontinuous? Continuous. Now let's look at our Y. Our Y, we're going to go from the bottom. There's no coordinate here, so I'm not going to graph anything. I'm going to just mosey along until my Y-axis hits a point, hits a point, hits a point, hits a point. This is Y equals -1, Y equals 0, y equals 1, and y equals 2. So our range is the set of all y, where y equals -1, 0, 1, and 2. Remember, you need to go from least to greatest. Let's try number 12. The lowest point I hit is here. Now, I don't have a point here, but I do have a point here. So a point exists. I'm going to fill it in. I'm going to map up, 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 up until I hit the end of it. It's closed because that exists. And then pencil up and I go off. This is at y equals -3. This is at y equals 1. So what's our range? It's the set of all y, where -3 is on the lowest, 1 is on the highest. -3 is included, 1 is included, and our range, or y, is in the middle. Bravo! This is going to change slightly when I have a graph like this. Anytime the graph goes to the end of the picture, that means there's actually an arrow. That arrow really helps me out with how I'm going to draw this. Let's start with our X. Open or closed? Closed. Pen down. I'm going to draw part of it, part of it, part of it. There's a graph, 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 graph. Huh. I get here to an arrow. Well, an arrow means it's going to keep going, which means my ruler is going to keep going, but I don't want to draw to the end of the page. So I'm just going to put an arrow to say I keep going. This inequality, remember, x goes first, your variable goes first, is x is greater than or equal to 0. If you've never seen the trick, as long as you're in standard notation, which means variable first, the arrow of the inequality matches the arrow of the ray. Our domain is the set of all x, where x is bigger than or equal to 0. Try the range. Map your lowest. Go up to the last place you see it, and when there's an arrow, add it. Again, this is easier for me to turn sideways, so I can see this is -2. Oh no, it's -3. And this is going to infinity, so I have all of the y bigger than, meaning going to the right, of -3, but it can also equal -3. The set of all y, where y is bigger than or equal to -3. That is my range. Then it asks, what is f at input 3? Input 3 gives me output 0. We have the coordinate 3, 0. You should show both. You try f at 0 and f at 4. We're going to apply our arrows with these 3 graphs as well. All the way to the end, arrow. All the way to the end, arrow. I'm going to graph from left to right. It's an arrow here. And I'm going to map, 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 map. Arrow. So how do I write a solution that goes all of the x-axis? We've done that one before. You could say the long way, which the domain is the set of all x from -infinity less than x less than infinity, never equal because it's not a number, it's an idea. Or you can say the short way. The domain is the set of all real numbers. Now you have to tell me the domain. It is not the range I'm talking about. Let's map the range though. Oh, we are starting with an arrow, and the arrow is at the bottom. And I'm going to map up, 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 up to there. I'm going to turn my graph sideways and say, well, if I put my variable first, y, then my arrow should match my arrow. And my number is 4, and I get to equal 4. So the range is the set of all y where y is less than or equal to 4. Try your domain and range for 15 and 16, as well as your function notation at the bottom. How'd you do? All right. Moving along here. I'm going to skip a page and go to this one. Let's see what you know for function or not a function. For every problem on here that is not a function, I want you to circle the letter that is not a function. I find it real helpful to use my ruler for this as well. I hit multiple places here, not a function. 1.1.1.1.1.1.1.1, multiple points right here, not a function. Multiple points, not a function. Finish finding your functions and not a functions. I found 12 not functions. I want you to go back through and put a star on all the ones that are discrete or discontinuous, meaning you have gaps inside your function graph. This one's discontinuous or discrete, 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 discrete. They all have gaps in them. Now this has a continuous step in it. This has a continuous step in it. This has a point, a point, a point. All right. Now, at the top of the page up here, I want you to put what the term is that, or the phrase we would say that is not a function. Go ahead and write it down. How'd you do? I'm going to finish putting on our not functions. I is kind of funny. This is one of the few graphs that the arrow doesn't actually go up. It's going to tell you that you're just going to keep having this pattern over and over and over. It's kind of cool. All the rest do have arrows. All right, let's go to the next page. This time, I want you to go through and write, is it a function or is it not a function? We're going to use F for function and F for not a function. Check your answers. The one that's easiest to confuse is number 12. And again, I like my ruler to be able to see that I hit both of them at the same time. Let's also star where our discontinuous or discrete functions are. And finally, let's write the definition that we would give for function. You put it at the top of your paper and see if you get it right. Yes, function, each input goes to exactly one output. That would be the answer we would give for 18, for 17, for 13. They'd all have the exact same function answer. All right, the next thing we need to do is we need to talk some function notation. Function notation tells us our inputs and outputs. Function notation comes from all of the different mappings that we've done. Function notation. On this page here, it actually gave us a clue that f at -3 means -3 is your input. You plug it in for x. So if I see this number here, this is an input. But if I see f at x equals, I'm not given x, I'm given the whole thing. That's our output. And you'll plug it in for y. It's often easy to confuse x and y in function notation. And this is where we actually have, in a weird order, this page. I believe it's page 4. Turn to your page 4 and let's go through this together. Normally when we have an equation, we have x and y. F at x replaces y. We read it as the value of f at x or f of x. I say f at x. And I like to say f at input x. The parentheses are not multiplication. We have letters to name the function, just like we have last names. It differentiates us from each other. So let's look at an example here. Y equals 3x plus 2. What is my input? X is the input. What is my output? Y is the output. So if I want to change it to function notation, I would say f at x equals 3x plus 2. What x is our input. Whatever goes here goes here. So for example, if I said f at a, it would turn into 3a plus 2. If I said f of -1, it would turn into 3 -1 plus 2. Substitution parentheses are going to be my favorite tool to use for this. Rewrite this function so it is function notation. That means instead of y, we're going to write f at x. I want you to do that for A and for B. Here, I just get f at x equals -3x plus 4. This one was a little bit different. If I just swap it out, I would see 2, and instead of y right here, I would have f at x. This doesn't look very helpful to us, but it turns out we can actually do the math. If I wanted to solve for y first, I would divide every term by 2, and I get y equals 3x minus 5. Well, it turns out I can do the exact same thing over here and divide everything by 2. 2 divided by 2 is 1, so I just get f at x equals 3x minus 5. So what is my input? My input is x. What is my output? It's the whole f at x, or the expression 3x minus 5. Function notation given a value of a variable. In function notation, if I'm just given a variable, using function notation allows me to say very simply, take function x, f, plug in 3 for x. Take function g, plug in -4 for x. Take function h, plug -1 in for the input. So that tells me this 3 is an input, which gives me the coordinate 3 comma something. This 4 is an input, which is going to give me an answer, -4 comma something. This is an input. It's going to give me -1 comma something. You will need 2 parts of your answer. The f at x equals the number and the coordinate, whatever your input is, whatever your output is. So let's try f. This is 3. Whatever x is has to match the parentheses, squared minus 1. I'm going to match my input in here, 3. This is now just a calculator problem that I need to type in. So I'm going to do 3, parenthesis 3, squared minus 1. We get that our output is 26. F at input 3 is 26. That's the coordinate, 3 comma 26. Try G and see how you do. Let's look at H. Now H is an absolute value, and there's a couple things we need to remember about an absolute value. One is that we can't use normal parenthesis rules. We're going to have to figure out the math here and keep our absolute value. So I'm going to just do -5 parenthesis -1 minus 2. I get 3. Now the absolute value can't be used until we explode it. Well, whenever I have the absolute value of a number, I turn it into parenthesis +3. Well, that's just 3. So H at -1 is 3. Take a moment to try 4 through 9. Pause the video. and then check back to see how you do, because I'll give you the answers. How'd you do? Did you rock it? Did you find mistakes? Did you notice that we have some hidden vocab? If my input is 0, I have a y-intercept. If my output is 0, I have an x-intercept. So what would this one be? Well, my input is 0. This is a y-intercept. Now, this is all fine and well, but what if we had something harder? What if instead of the input, I gave you the output? That could very well happen. So here's what I want you to do. I want you to look at number 5. And instead of it being that problem, we are going to change it just slightly. And we're going to say, what if it actually said g at x equals 1/2? For k at x. For number 9, I want you to say, what if instead of input -4, it was output -4? Take a moment to figure out what you would get for an answer and how you would solve it. How would you set it up? What would your coordinate look like? Look at number 9. How would you set it up? What would your coordinate look like there? Now, I'm not going to leave you hanging. I am going to go through and show you how to do all of this. For number 5, my coordinate would be something 1/2. I have the whole output is 1/2. So I would write my template, but I would swap the whole output for 1/2. Subtract 3 turns into add 3 to move it. 2x turns into divide by 2. And I get 7/4 or 1.75. That answer goes up here. Now, how would I prove if I'm right? I can go back to the original problem. G at x equals 2x minus 3. I said my output was 1/2, which is 2 times 1.75 minus 3. Let me just go ahead and type that in. 2 times 1.75 minus 3. That is 0.5, which is the same as 1/2. Or you could also just say, hey, what if I just figured out g of 1.75? Well, that's 2 times 1.75 minus 3. That's still 0.5, which is what I got for an output. Try your k at x equals 4 now. I'll even leave this up for you to look over. G at x equals 1/2. I got 7/4 1/2 or 1.75. Double checking your 6, -2, 8. And if k at x equals -4, I get 8, -4. Here are the rest of the answers for the problems that you've been doing on this page. Double check which one goes where. Pause the video if you need to. We can make these even harder. And sometimes what we get is k at 0 plus 3, or h at 0 minus 7, or 2 times f at -2 plus 3. All of these are doable, but we have to think a little bit different. I'm going to do the first one, k at 0. And I'm going to walk you through 2 ways that you could solve it. The first way says, hey, we already solved k at 0, didn't we? K at 0 is just 0. So I can take that problem and say k at 0 plus 3. Well, k at 0 was 0, which is 0 plus 3, which is 3. So I would get the coordinate when I plug in 0. I get 3 instead of 0 this time. If you want to do it all at once instead of 2 different steps, we'd say, okay, k at 0. Well, k at 0 had a formula. K at 0's formula was to take negative 1/2 x and plug 0 in for x. Then this is all just a calculator problem. And plugging it into my calculator, negative 1/2 times 0 plus 3, I still got 3. So I got 0, 3. Brilliant. You have 2 problems here to try. Pause the video, see what you can do, and I'm going to give you both solutions to help you see if you're understanding or not. So remember, we had some solutions. That h at 0 has 2 ways that it could be solved. The 2 times f at negative 2 plus 3 has 2 ways it could be solved. How'd you do? These are some of the hardest problems you could do at this point. And if you were able to get them, you're understanding a lot. Let's go to the back side of that same page. Use what you know to do example 3 now. Pause the video, set it up, and I'll show you my solutions in just a moment. In looking at this problem, I can see that this is an output is 9, which means 9 is my output. So I will set up my equation, I will solve, and I did a double check to prove it's true. Take a second to check the work for the number 11. This was my double check. It was not my answer. 6 was my answer. This was my double check. I plugged output and input in to prove that I had it right. Or I could just plug the input I found and see if I got the output again. Number 4 is all about interpreting functions. For example, 4. When we interpret functions, we have to understand what each of the different pieces mean. F at T is the temperature outside in degrees Fahrenheit. T is hours after 10 a.m. So let's just start there. If I said T equals 0, then that means 0 hours after 10 a.m. Well, what is 0 hours after 10 a.m.? 10 a.m. If I said T equals negative 4, that would be negative 4 hours after 10 a.m. Well, that sounds funny. Negative 4 hours would mean I went back 4. So 10, 9, 8, 7, 6. That's saying 6 a.m. What would it mean if I said T equals 7, T equals 8, T equals 3? 7 hours after 10 a.m., 8 hours after 10 a.m., 3 hours after 10 a.m. In basic language, that's just saying, well, 7 hours after would be 5 p.m., 6 p.m., 1 p.m. All right, so now we know how to read our input. Let's look at what our output is. If I say F at 0, I'm saying, what is the temperature? Zero hours after 10 a.m. F at -4 would be the temperature in degrees Fahrenheit, of course. -4 hours after 10 a.m. F of 7, F of n. This would be the temperature in degrees Fahrenheit, 7 hours after 10 a.m. Now remember, 0 hours after 10 a.m. would be the same as saying at 10 a.m. or -4 hours would be at 6 a.m. 7 hours after 10 a.m. would be just saying or at 5 p.m. When I leave a variable in, it gets a little bit tricky. This is the temperature in degrees Fahrenheit, some hours after 10 a.m. What's cool is if I add an equal sign, then I just add the word is. If I say 7, then I'm saying 7 degrees Fahrenheit. Now, take a moment to see if you can use that template to decode A, B, or C. Did you get an answer? The long form isn't so bad to do, but it is a little bit unwieldy. The temperature in degrees Fahrenheit, 0 hours after 10 a.m. is 75 degrees. What would that be in common language? At 10 a.m. it was 75 degrees. Try B. Pause the video if you haven't already got an answer. The temperature 3 hours after 10 a.m. is n degrees Fahrenheit. That's actually a mathematical question. What temperature was it at, well, 3 hours after 10, we said was 1 p.m. There's your story problem version of the set notation. The last one uses all of this plus an inequality. So F at 1. Well, F means the temperature at 1 hours after 10, which is 11 a.m. That's easy enough. And then F at 8. How would we say F at 8? It would look pretty much the same, wouldn't it? that the temperature at 8 hours after 10 a.m. or 8 hours after 10 a.m., meaning 6 p.m. We added the symbol in the middle. That symbol is greater than. So our interpretation is the temperature at 1 hours after 10 a.m. is greater than the temperature at 8 hours after 10 a.m. Or, in simple terms, the temperature at 11 a.m. is warmer than the temperature at 6 p.m. Done. All right. Example 5 is making a graph. Take a second to make a graph for your input-output table. And then I would like you to also find your domain and your range. With this table, we were given an equation first. Because we were given an equation, our points are connected. Knowing that our points are connected gives us a different domain or range. Now, there's a couple rules for this in my class. One, whatever you put for your coordinates, you must continue to the entire end of the graph. Now, you can do this. We're going to start with 0, 5. And I have a slope of 2, so I'm going to go rise 2, right 1, rise 2, right 1. No more graph. Fall 2, left 1, fall 2, left 1. And I'm going to keep falling 2, going left 1 until I get all the way off the graph. And then, because it's an equation, I'm going to graph it. Now, we can label this. This graph is graph F, or graph F at X. Now, our domain, going from left to right. Arrow, connect, arrow. Our domain is all real numbers. Our range, arrow, connect, arrow. Our range is all real numbers. Be sure to label domain and range. We're going to skip example 6 for a moment. I would like you to practice graphing a function that seems a little crazy on your own. Turn back. So we were on this page. So I went back 1, 2.5 pages. Take a moment to graph this. This is what's called an exponential function. So I'll give you the answer there, but I want you to take a moment to graph it. Pause the video, and let's see how you do. Did you get that this was connected? And what's going to happen is our points, if we keep going, we're going to get closer and closer and closer to 5. So we can find our domain. Our domain is all real numbers. And our range, if we drew it out, would start here at 5. And it's technically not going to equal. It's what's an asymptote. And it's going to go this way. So our range is the set of all y, where y is greater than but not equal to that number we kept getting really close to, 5. All right. Let's go back to that helicopter problem. Example number 6. Hopefully you're hanging in. Hopefully you are learning a lot. Hopefully you are making some ahas. Number 6 is the hardest type of story problem where you have to put everything you've done together. The nice thing is, after this, the 2 worksheets you have left to finish before converting linear equations are all things you've already done. You'll be able to practice them. You'll be able to see how you can do and just check your answers against mine. And the graph shows the number of miles a helicopter is from its destination. This is important. Miles from its destination. So if I say 100, that means 100 miles from its destination on its first flight. So here, this point here is 0, 300. Since my input is 0, this is an x-intercept. Sorry, y-intercept. This is 300 miles from destination. This point here is the coordinate 0, is 3, 0. My output is 0. This is an x-intercept. That 0 is 0 miles from its destination. I am where I'm trying to get to. X is the hours it travels. 0 hours traveled. I haven't flown anywhere yet. I'm 300 miles away. How many hours traveled is this? After 3 hours traveled, how far am I from the destination? 0 miles. I have made it. That is what this means. Now, on its second flight, the helicopter travels 50 miles farther and increases its speed by 25 miles per hour. This is the second flight. Now, it's not in slope-intercept form. F at x equals 350 minus 125x is not in slope-intercept form. We could change it into slope-intercept form. And then we can see that this is our slope. That is how much faster it was traveling. So we are closing 125 miles each hour. Originally, he was only traveling then how far? If this is 25 miles per hour faster, how fast was he traveling before? Down 100 miles for every 1 hour. That's 100 miles per hour. He was traveling towards his destination at 100 miles per hour. This is our 25 miles faster. Originally, he was 300 miles away. Now he's 350 away. This is our y-intercept. Remember, a y-intercept is never a number. It's always a coordinate, 0, comma. So what's it want to do? It wants to know where the helicopter is time-wise when it gets to its destination on the second point. Now, destination is how many miles away? This is the tricky question. If I'm at my destination, I'm how many miles away? 0. Destination is the output. So I'm asking myself, what do I get if an output is 0? We're going to replace this entire output with 0. And then it just becomes an algebra problem to solve. Take a second, solve this out. All right. So we get the coordinate 2.80. If it's a story problem, though, we have to answer very specifically. A story problem is a function on its own. Story problems are functions. Story problem input, sentence output. Using your information here, how could you interpret this problem to get full points? Do you got an answer? Pause the video and write one down. I said the second flight took less time since it took 2.8 hours instead of 3 hours to get to the destination. How'd you do? Did you learn a lot? Let's take a moment and bounce to the next page in your packet and see if you can remember how to do the mapping, the table, the graph, and tell me if it's function notation or not. There's something very, very important that we need to realize with our ordered pairs here. This is not correct. What do you need to add here to make this correct? If you thought to yourself, it's missing the squiggly brackets, you're absolutely right. What is your mapping missing to get you full points? If you said it has this bubbles, but it's missing the domain and range letters, you're right. Thank you for fixing it. Fill this out. Is it a function or not? Remember, there are 2 statements that you are going to use, and you have to use the full statement to be able to get points for is it a function or is it not a function? Do you remember what those statements are? Function. Each input goes to exactly one output, not a function. Function blank goes to both output blank and blank. See what you can do for numbers 1 through 4. Fixing the table and the charts where you need to. Number 2 tends to get messed up sometimes. And often what will happen is if you graph your points incorrectly here, We have 1, -3, 2, -3, 3, -3. If you accidentally read a point backwards, then you'd get not a function, but it's because this point, for an example, didn't go to the right place. In fact, sometimes we miscount, and it really should be redone correctly. So I'm going to do that one. 1, -3, 2, -3, 3, -3. I'll fix this and edit. We have 1, -3, 2, -3, 3, -2, 4, -2. It is a function. Finish up the page and check. Did you get your functions right? You should have full sentence, not shorthand like this. No credit. Incomplete answers. Don't write it that way. Did you remember your set notation here? Did you remember to label your domain and your range? If so, you're doing awesome. All right. Flip back to page 2. If you are understanding how to do your function notation, you should now be able to complete this page rather quickly. Pause the video. Do these first 6 examples. And let's check if you got the answers right. How'd you do? Did you notice that with an input of 0, you have a y-intercept here? If you did, you're brilliant. Keep going. If you didn't, now you know. See if you can spot another one. Complete this half of the table. What do you get when you plug in your values? Are you using your calculator to help you out? If so, you are likely going to get it right. If you don't use your calculator, there's a good chance you're going to make a computation error. Why? Well, because we kind of freak out on tests sometimes, don't we? The calculator is not your enemy. Your calculator is there to help you out. Remember, you not only need your input and output in function notation, you need to have your coordinate as part of your answer. You ready to check? Remember that you must have function notation and the coordinate. Did you get your table right for the last part? When you graphed it, did you fill in as many points as possible? Did you ask yourself, do I connect or do I not connect? I have an equation. I connect. Challenge yourself. Can you identify your domain and your range here? What about your x-intercept? An x-intercept is where the output is 0. Can you find your y-intercept? That's where your input is 0. The y-intercept is a little hard to figure out, but it should be 0.6 if we calculate it exactly by plugging in 0 for f at x and solving for x to get our input. You don't even have to be able to read it on your graph. If you can get this concept down, you're set for the next unit. Backside. -3 is an input. I find -3, I get 2. 8 is an input. I find 8, I get 4. 9 is an output. I find 9, I get 2 for x. 0 is an output. I find 0 in the output, I get 20 for x. 2 of your problems over here shouldn't have worked. We didn't get -1 as an input. We can't tell using this graph. I can tell that f at x equals -1 means x equals 0, and I get the point 0, -1. Hey, that's a y-intercept. F at x equals -5, I can't tell. But I can tell that f at -5 equals 8, giving me a coordinate, -5, 8. Try the last 4 problems. How'd you do? Hopefully by now you are rocking it and you are finding confidence in how to do function notation. There's 1 page left. And in about 15 minutes, you will have reviewed an entire unit, or at least the first half of it. We've got a lot more we're going to do this year. There are 3 forms of linear equations. Linear equations are lines. It can have a positive slope. It can have a negative slope. If I have y equals mx plus b, this form is slope-intercept. Your slope is m. Your intercept is a coordinate, 0, comma, whatever b was. The second form is called point slope. It is important to know that you must see the subtraction to have point slope get a point. Your point is x1 comma y1 if you have a negative. Your slope is just m. So for example, if I had y plus 7 equals 3 times x minus 4, I have a subtraction here. So my x1 is 4. I don't have a subtraction here. So I would change this to minus -7, which would give me that my y1 is -7. This form is called standard. It has 2 special rules. It cannot contain fractions or decimals. The leading coefficient must be positive and in standard notation. That means powers from greatest to least and alphabetical order. Negative 3y plus 7x equals 10 is not standard. It's not in standard notation, so it's not in standard form. So we would need to rewrite this as 7x minus 3y equals 10. That's now in standard form. I allow you in my class to abbreviate that slope-intercept is SI, point slope is PS, and standard form is SF. I'm going to do 2 of these with you. Then I want you to try doing the rest of them. And you're going to add a separate step 12. Your separate step 12 or problem 12 is use the point and slope from the slope-intercept form to get a new or first point slope form. This is going to be your number 12. You're going to also do this. I'm going to do number 6 with you. I'm going to do number 10 with you. I'm going to look at this first. Is this in point slope form? Technically, yes, but I'm going to change it so I can see my subtraction. Y minus negative 7 equals 4 times x minus 3. Then I'm going to label it as point slope. Where the line is where the label is. I'm going to take my y minus negative 7 equals 4 times x minus 3, which is point slope, so I'll label it. And I'm going to put it into slope-intercept form, which is really just solve for y. I'm going to isolate y. So I get y plus 7 equals 4x minus 12. Subtract 7. Y equals 4x minus 19. X is before constants. This is now slope-intercept. Standard form says I have to isolate the constant. That's right here. So I'm going to subtract my 4x. X is before y's. This is not in standard form yet. No fractions or decimals? Good. Standard notation? Good. But positive leading term. So I need to go through here and I'm going to multiply each term on all sides by negative 1, giving me 4x minus y equals 19. That is my standard form, and so is this line here. Try doing number 9. How'd you do? Now, whenever I have slope-intercept form, I'm going to go ahead and do the part 12 here. I have a slope. It's 4. I have a y-intercept. It's 0, comma, b. So now I want my new point slope, which is y minus the y number equals m times x minus the x number. Or you could say y plus 19 equals 4 parenthesis x minus 0. If I don't give you point slope to begin with, you can find it every time. That's the purpose of number 12. All right, we're going to use that for 10. Standard form. Well, right now, y equals 1/2 x plus 4. Ooh, that's one of our forms. Which one? Do you get slope-intercept? I'm going to take my y equals 1/2 x plus 4, and I'm going to isolate the constant. Isolating the constant, or solve for the constant, is standard. So I'm going to subtract 1/2 x, negative 1/2 x, x's before y's. All right, constant isolated, check. No fractions or decimals, not check. Because there's a fraction, I'm going to take the denominator, and that's what I'm going to multiply everything by. Times 2, times 2, times 2. Negative 2x plus 2y equals 8. Oh, not 2x, 1x. We better make sure we're using our calculator. Negative 1/2 times 2, negative 1. Almost had a big mistake here. Good thing we use our calculator to check. Constant isolated? Check. No fractions or decimals? Check. Leading term positive? Not check. So we're going to multiply everything by negative 1, giving me x minus 2y is negative 8. This is standard form. This line was standard form. Now your number 12. I also want a point slope. Where can I find a point? In slope-intercept form. In slope-intercept form, you have a slope, 1/2. You have a y-intercept, 0, a number. So then my point slope form is as easy as y minus number equals m times x minus a number. My slope was 1/2. My x number is 0. My y number is 4. We're done. All right. Your job is to do that for all of the rest of the problems. Take a second, solve it out, label each type so you can recognize them easier, and we will check how you did. Well done.